All right, in chapter 11, we get into dealing with area. Some of your basic formulas you already know, but we're going to get into some of our other shapes that we're not as familiar with, and some other ideas that will help you find the area of certain figures. So, in our opener here, to find the area of a figure, you've done problems like this before where you just need to break it apart. Right? So, we're going to break it up. There's different ways you can do it, but for our sake, we're going to come right here. We'll break it apart into a rectangle and a triangle. So on the right hand side, we have this rectangle here that is 6 by 8. So we do 6 times 8 gives us 48. Now we still need to add that triangle to it. Since my bottom here is 6, that means this top length of that rectangle was 6. Since our whole length here is 14, that tells me that this piece here is 8. Likewise, as I come up the side, I know my whole length from top to bottom is 8. The length we have here right now is 5, which tells me that this piece here would be 3. So I have this triangle over here that has a base and a height of 3. Base times height divided by 2 tells us the area of this triangle is 12. So our overall area here is 60 units squared. Right? As I said, we're going to go through some of our basic shapes. We'll talk about our triangle, our square, our rectangle, but we will get into some other shapes. We're going to talk about some trapezoids as we go through the chapter. We'll also talk about your parallelograms. As we mentioned before, your bases of a parallelogram, they are a set of sides that are parallel. So when we look at your bases of a parallelogram, it is either pair of parallel sides. So there's two different sets you could look at. In my parallelogram here, I could look at the top and bottom being a set of bases, or I could do the left and the right being a set of bases. It is either pair of parallel sides. The key is when you go to pick your height. The height of your parallelogram, it is the perpendicular distance between the bases. Right? There are two different heights in your parallelogram. If you pick the top and the bottom as your bases, then your height is the perpendicular distance from the top to the bottom. That is a height. However, if you pick the left and the right as your bases, then we want the perpendicular distance between there to be your height. Right? So make sure you are picking the appropriate height to go with the appropriate base. As for some of your area formulas, as I said, some of them you'll already know, such as your square. Area of a square is just your side squared. So you take the one side times the other. But just keep in mind that those sides are going to be congruent. So it is s times s, which is s squared. For a rectangle, we've talked about it being length times width. Typically, we'll talk about it in this class as base times height. That way our terminology stays consistent when we look at your different shapes. Always talking about a base and a height. So your area here is just BH, base times height. A parallelogram actually has the exact same formula. However, keep in mind that your base and your height are not necessarily going to be the two sides. Your base will be one of the sides, but your height is that perpendicular distance between them. So if I'm doing the left and the right as my bases, it is that perpendicular distance from top to bottom. So it is still base times height. Just keep in mind, in a parallelogram, this is not the height. And the other one we'll work with is your triangle. Right? Area equals 1/2 the base times the height, or your base times height divided by 2. Whichever way you want to talk about it is up to you. Right? But once again, keep in mind a base and a height must intersect to form a 90-degree angle. No matter what type of triangle you have. In an acute triangle, in a right triangle, in an obtuse triangle. Now, two quick ideas to talk about before we start looking at some examples. The first one is your area congruence postulate. It just says that if two figures are congruent, everything about them will have to be the same, including their areas. If two polygons are congruent, then they will have the same area because they'll have the same base, they'll have the same height. And our other one is what we were allowed to use in the opener. Your area addition postulate says the area of a region is the sum of the areas of the non-overlapping parts. Meaning I can take a shape like this and I can break it apart and find the individual areas and add them up. Right? I can take this, break it up this way, find the area of the top, find the area of this little right-hand piece, and add them together to get the whole thing. What that non-overlapping parts means, what I cannot do, I cannot find the area of the whole top rectangle and then go and do the entire right-hand rectangle because these two overlap. I'm counting it twice. I cannot do that. So find the area of our parallelogram. Area equals, base times height. Now, the key is what base and height do you want to use? If we're talking about the top and bottom being the bases, then it is the perpendicular distance from top to bottom. So that is 4. So one thing we could do is 9 times 4. If instead you want to use the left and the right as your bases, that's fine to do. But now that perpendicular distance between them is 4.5. So we could have 8 times 4.5 instead. It doesn't matter which one you do. Both of them give you an area of 36, and in this case we just have units squared. Okay. Taking a look at our next one here. We have our triangle. The whole base on the bottom. 45 and 21 gives us our whole base to be 66. So we have 66 times 28. And then I got to divide that by 2. We get 924. On the right-hand side, we have our parallelogram. So my area is base times height. My base is 17. My perpendicular height between them is 7. So it's 17 times 7. Now, 10 could be a base, but I don't have a perpendicular height between its other base. So I cannot use the 10 at all. So I do 17 times 7. We get an area of 119. And we're just looking at units squared in both cases. And our next one says the base of the triangle is 4 times its height. So whatever the base is, it is 4 times the height. Well, unfortunately, I don't know what the height is. So I'm just going to call it x. The base of the triangle is 4 times that height. So it'll be 4x. Area of a triangle is base times height divided by 2. So my area is base, which is 4x, times my height, which is x, divided by 2. So I got 50 equals 4x times x is 4x squared. To solve my equation, first thing we got to do is multiply both sides by 2 to get rid of my divided by 2. So we have 100 equals 4x squared. Next step, we'll divide by 4. So we have x squared equals 100. And finally, we take the square root of each side. Oh, I'm sorry. Correct, divide by 4. 100 divided by 4 is 25, not 100. And then we take the square root of each side to get x to equal 5. So if x is 5, that means my height is 5. My base was 4 times x. 4 times x will give me 20. So my height is 20. Right? Next problem that's here says a robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. About how long does it take for it to clean a carpet covering a room with the dimensions shown? So first thing I got to figure out is the area of my figure. So we'll break our figure up. Once again, there are different ways you can do it. So we can come straight across if we want to. We have a square on the bottom. 5 times 5 is 25. We have this rectangle on top. Since this length here is 5, then this length here must be 4. Because they have to add to 9. So I have this rectangle on top then. That's 9 by 4, which is 36. 36 plus 25 tells me my overall area is 61 meters squared. Now my vacuum cleaner can do 2 square meters in 8 minutes. I need to do 61 square meters, and I want to figure out how many minutes that is going to take. So all we do is cross multiply. 2 times x is 2x. 8 times 61 is 488. Divided by 2, we get x to equal 244 minutes. All right, next problem says a parallelogram has an area of 133 square feet and a height of 19 feet. What is the length of the base? Area of a parallelogram is just base times height. My area, they say, is 133. My base, we don't know. We'll just call it b or x if you want to. The height is 19 feet. So to solve for my base, we just divide both sides by 19. I have 133 divided by 19 gives me the base to be 7. Looking back at my units, everything was in feet, so my base is also in feet. Last problem then. It says in example 3, that was our robotic vacuum cleaner. Suppose there are 4 sections of carpeting measuring 1 meter by 2 meters that are covered and cannot be swept. So I have some furniture pieces. There are 4 of them that measure 1 meter by 2 meters. So each one is 2 square meters. About how many hours does it take for the robotic vacuum cleaner to clean our carpet? Well, we started off saying our area had 61 square meters to it. Well, now I have 2, 4, 6, 8 square meters that are covered and will not be swept. That means I have 53 square meters that are left. My robotic vacuum cleaner, it does 2 square meters in 8 minutes. I now have 53 square meters, and I need to know how long it will take. So we can cross multiply here. We get 424 equals 2x. Divide by 2, we have x equals 212. Now, keep in mind, that is 212 minutes. It says about how many hours will that take? So we divide by 60, and we get x to equal approximately 3.5 hours, or 3.5 hours. if you would prefer. All right, brings us to our homework here. Pages 723 to 724, the numbers you see there. All right, please let me know if you have any questions.